Okay, this is going to be another relatively short video. We are going to continue on our conversation about exponents, and we are going to talk, we just talked about the product rule, or power product. Now we're going to talk about the quotient of powers rule. Pretty straightforward. When you hear the word quotient, we think division. So the basic idea here is that if we have a like base being brought to an exponent in both the numerator and denominator, we can simply subtract the denominator's exponent from the numerator's exponent. And to illustrate that, let's take a look at, I've got 6x's up top and 4 at the bottom. So realistically you can see that 4 of those would cancel, leaving you 2 x's, but another way to think about that is that's x to the 6th over x to the 4th, subtract 4 from 6, and you get x squared. Not too much more complicated than that. So if you had, say, p to the 9th over p squared, you've got p to the 7th. If you had m to the 10th over m, when you don't see an exponent on a given number or letter, it's understood to be 1, so that's 10 minus 1, which is 9. Careful with something like this. Remember, the bases have to be the same. We would simply say this here can't be simplified. Unless the bases are the same, we're not going to get anything done. And you can have, obviously, in the same problem, multiple variables. So that's 8 minus 4 for A, which is 4, 9 minus 1 for B, which is 8, and 3 minus 2, which is just 1. Coefficients work just like they did with the product rule. Just like 8 divided by 2 is 4, 8x to the 7th divided by 2x squared would be 4x to the 5th, because we subtract the 2 from the 7. You can sometimes have coefficients where you can simplify without eliminating. Here we know that 8 and 12 are both divisible by 4, so that would be a 2 over 3, and x is 7 minus 1, which is 6, and that always goes in the numerator. And last example, you can even see this with binomials. But exact same principle. 5 minus 2 is 3, and that's all there is to it.